Okay, so we're going to talk about solving proportions, writing proportions, and similar figures. We will again talk about scale drawings the following week. Okay, so let's first start with just plain solving proportions. Okay, so if you turn over in your foldable, you have two examples here. Okay, we're just simply going to solve proportions. So we know that we're going to just cross multiply and divide. Okay, what we can also do is we can also set up an equation. So we can set both of these equal to each other. So we have 6x equals, we do 15 times 8, which would be 120. Okay, so it's just like solving a one-step equation, just like you saw in 6th grade. So if we part our river, as we call it, and we divide each side by 6, okay, because the opposite of multiplying is dividing. So we'll just divide each side by 6. Okay, those cancel out. X is what's left. We bring it down. Okay, so X is equal to 120 divided by 6. Okay, and we know that 120 divided by 6 is going to give us 20. Okay, so X is equal to 20. All right, and if we were to check that, we could put 20 back in where X is and do 20 times 6, which would give us 120. Okay, and then we know that 15 times 8 gave us 120. So 120 does equal to 120, so we know that is correct. Okay, the next example is x over 20 equals 8 over 4. We do the same concept there. We're going to do 20, cross multiply both. Okay, so that's going to be 4x equals 20 times 8, which is going to give us 160. Okay, all right, that's multiplying. Opposite of multiplying is dividing. So if we multiply by 4, we got to divide both sides by 4. Okay, that cancels out. We're left with the x. 160 divided by 4 is going to give us 40. So x equals to 40. Okay, so now that's simply just solving proportions. Okay, the next one we're going to do is similar figures, which we're going to talk about more next week, but we're going to go ahead and hit it here. All right, so similar figures. Let's open that tab. Okay, so here we have two rectangles. Okay, and we know that similar figures, they could be the same shape, but not necessarily the same size. Okay, and we know that sides or corresponding sides are proportional, corresponding angles are congruent or equal. Okay, so the first thing that we're going to do is we're going to circle and underline those sides that correspond to each other. So then when we get ready to set up our proportion, it will be easy for us to see what we need to put over what. Okay, so we know that this is a rectangle, and we know that these two sides will be the same, and these two sides will be the same. Okay, so if we were to redraw, which is what I would suggest everyone to do, redraw and relabel, the x would be on this side. Okay, so we know that the 6 and the x correspond with each other. Okay, and this 4, I'm going to underline this, sorry. This 4 and this 6 correspond. Okay, so now we have our corresponding angles here. Excuse me, our corresponding sides here. So we're going to set up our proportion here. Okay, so now it just depends on which way you want to set this up. You can work with one shape and then go to the next shape, but you have to make sure that you keep the corresponding sides in the right position. Okay, so what I'm going to do it both ways. So the first way I'm going to do it is I'm going to work from small to big. Okay, so I'm going to do 6 over x because those two correspond. So 6 over x. Okay, so now 6 is talking about the small one. So I'm going to go back to the small one. So 4 over this 6. Okay, so I went from small to big and then went back small to big. Okay, now the other way you can write this is you could work with one shape at a time. Okay, so I could do 4 over 6. Okay, and which one corresponds with that one? It would be the 6 here. So 6 over x. Okay, and how I know these are set up correctly is because if I see which one when I'm cross multiplying, if I'm multiplying the same number by itself, by the same numbers on both proportions, then I know that they are set up correctly. So it doesn't really matter which one I solve, it's going to be the same answer. Okay, so I'm going to multiply 6 times 6, and then I'm going to multiply 4 times x. Okay, I'm going to stick with writing them, setting them up as an equation. 4x equals 36. Okay, now again, draw my line down the equal sign. I'm going to do the opposite here. I'm going to divide by 4 on both sides. I'm left with my x here, so I'm going to bring that down. 36 divided by 4 is going to give me 9. So x is going to be equal to 9. Okay. How do I check myself? If I put 9 here, 4 times 9 will give me 36. 6 times 6 give me 36. So I know both of them are equal. Okay. All right. Now, we jumped down to example number 4, which was similar figures. We're going to go back up to the writing proportions. Okay. So let's go to this example here, the writing proportions. Okay. This is what we call indirect measurement. Indirect measurement. Okay. Of course, we're going to use our UPS strategy that we have been working on in class. So we're going to first read this problem. A utility worker is 5.5 feet tall. Okay. That's an important piece of information. We always say we're going to circle. Sorry that it's blurry. Circle that. And it is casting a shadow of 4 feet long. Okay, we're going to circle 4 feet long. At the same time, a nearby utility pole casts a shadow of 20 feet long. We're going to write and solve a proportion. That's an academic vocabulary word. Okay, we're going to find the height of the utility pole. So we're going to write and solve a proportion to find the height of the utility pole. Now, when you're dealing with indirect measurement, my suggestion to you is to draw the picture. Okay, now Ms. Wilson is not an artist, so just bear with me here. So a utility worker. So I'm going to draw my utility worker here. I'm going to draw my little stick person. Okay, he is 5 feet tall. 5.5 feet tall. So I'm going to put 5.5 feet right there. Okay. Now, he casts a shadow that's 4 feet long. So here's his shadow. We're going to pretend like that's his shadow. And this is 4 feet. Remember to put my units. Okay. At the same time, a nearby utility pole casts a shadow of 20 feet. So I'm going to draw my utility pole here. Okay. And it casts a shadow of 20 feet. Okay. What is the height of this utility pole? We don't know that. So if you notice here, it's still showing similarity here, right? Okay, we can still set up a proportion to solve this. So we're going to do the same thing we did. We're going to circle the sides that correspond and underline the sides that correspond. Okay, so the 5.5 is in the same position as this x. Okay, and this 4 is in the same position as this 20. Okay, so we're just going to simply set up a proportion to solve this. Okay. All right, so now I'm going to go here, 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 here. 5.5 over x. Go back to the person, 4 over 20. Okay. Now, I'm just simply going to solve this now. I'm going to cross multiply and divide. Okay. So 5.5 times 20. Okay. That's going to give me 110. Okay. And I'm going to divide that by 4. Okay. So when I divide that, 4 goes in, it won't go into 1, it will go into 11 2 times. That becomes an 8. 3. It goes into that 7 times. It's going to be 28. I'm going to subtract. I get 2. Oh, excuse me. I need to add my decimal there and a 0. Bring that down. So now 4 will go into 20. 5 times. So the height of this utility pole is 27.5 feet tall. Okay. So that is what indirect measurement is. So we just went through solving proportions, writing proportions, and similar figures. We will do scale drawings on the next week.